to speak in Spanish. Hi, Simon.
Hello.
I hope you are doing fine. Well, I'm going to speak in Spanish to present you to the local folks. Así que Simón Martinelli es un Java Champion, Badin Champion, Oracle X Pro, con más de 3 décadas de experiencia como Software Architect, desarrollador, consultor y trainer. Como dueño de Martinelli LLC, se especializa en optimizar desarrollo full stack con Java y tiene un foco profundo en arquitecturas modernas y sistemas distribuidos. Frecuentemente comparte su experiencia hablando de conferencias internacionales como esta, escribiendo artículos y en su blog. Su pasión por enseñar se refleja en su reflejo dando lecturas en la Bern University of Applied Science y la University of Applied Science Northwestern Switzerland, donde enseña cursos de arquitectura moderna, sistemas distribuidos, tecnologías de persistencia y DevOps. Y nos va a presentar la charla CQRS meets Modern Java. So, without further ado, I leave you with Simon Martinelli.
Okay, thank you very much. I'm very happy to be here. Unfortunately, I don't speak Spanish, so I'm going to do my talk in English. I will talk about CQRS and will introduce you to this pattern and also show you that there are various ways to implement that or various stages where to go to. Andres already introduced me, so I will skip that and go into the talk. What I want to talk to you is about client-server communication. In today's applications, we usually use single-page application frameworks in the front end, and on the server we have, for example, Java with Spring Boot or Quarkus or any other of these Java frameworks. And what I realized in a customer project last year that there was not enough semantics on the client side when we were dealing with a RESTful API. So we had issues to understand on the client side. We were using Angular in that project. We had issues to understand what exactly was called on the server side. So we will see an example of this, I call that traditional style API backend application. And I try to explain how we may introduce CQRS to that to make it more readable and understandable. Now, something that I usually see in applications, for example, with Spring Boot, is something I call the mapping waterfall. By the way, this picture of the waterfall was created with AI, so that's the only AI part of my talk. I don't talk about AI, but I thought maybe my talk should have some AI. And the mapping waterfall here is something like you get the REST controller. There you usually have DTOs. These DTOs are then mapped to an entity. The entities may be processed by a service and finally passed to a repository to store to the database. When reading the data, the same thing happens. You get the REST API call, then you call the repository, for example, that returns an entity. Again, a mapper like object mapper, model mapper, or mapstruct is used to transform the entity more or less to the copy as a DTO and then return that from the REST control. And this mapping waterfall has some issues, especially when it comes to performance and when it comes to understandability on the API level. I created the example project. It's available on GitHub. CMACH is my username, and the project is called CQRS Meets Modern Java. You can also capture the QR code. It should direct you to this page. Now, let's have a look at the example project. In fact, the example project has two Maven projects inside. One is called CQRS and the other one is called traditional. So let's start with the traditional approach. This is a regular Spring Boot application. It uses a database behind the scenes. It uses a Postgres database, and I use test containers to start that. So that's not special. But let's start with the API. So here we see that we have DTOs. So what I have here is an order controller. We have a purchase order DTO. That's a class that holds an order. It has a order date. It has a reference to a customer DTO. The customer DTO has common fields like first name, last name, and so on. And then we have a list of order items, and the order items have quantity and also a product with a name and a price. So that's a tree-like structure for our purchase order, and we want to use that in our API. So on the API level, here on the order controller, we have various request mappings. For example, we have a post mapping to create a purchase order. Here we use the purchase order DTO. Then we map the purchase order DTO to a purchase order. The purchase order, in fact, is an entity that also has a customer, which is also an entity. And we also have the order item as an entity and also the product as an entity as well. So we have more or less a one-to-one copy of the entity model to the DTO model. And finally, what happens here, we first we look up the customer, then we can set the customer on the purchase order, and finally we save it. Then also in this API, we have a put mapping to update the purchase order. Again, here we use the purchase order DTO. And finally, we have a get mapping where we can filter by first name, last name, and we also have paging in place. We can set the page number and page size, and then we call a repository method. This here is a Spring Data JPA repository method that will transform into a query that will be executed to the database. The application runs, and I created some requests. I don't know if you know that feature of IntelliJ, but in IntelliJ you can create the file with the file name, for example, requests, and the file suffix HTTP. And this is kind of a HTTP client that you can use to test your API. It's similar to what you get if you use, for example, Postman. And here I have a GET request, and I can directly execute it from here. And I click on the button, and it takes a bit more than 2 seconds. So it returns all data. So I say that I want to have page number 0, and the page size is 9,999. That means I don't use paging, and return all the purchase orders that I have. Now, why does this take 2 seconds? I mean, it's a bit long. Have a look at the console. And if we look here, oh, that's a bit unfortunate. I have to restart it because it was run in debug mode. And it just did a restart. So let's go ahead and do that again. So we have the traditional request. And again, it takes 2.5 seconds this time. And if we look here in the console, we see a lot of SQL statements. So what happens here is the so-called n+1 select problem. And this problem is because if we go to our purchase order entity, we see that we have, for example, a list. And the list is mapped by a one-to-many mapping from JPA, and this is lazy loaded. So that means when the serialization mechanism of Jackson kicks in here, when we use the model mapper and map the entity to the purchase order DTO, it will trigger the lazy loading mechanism and create this n+1 select problem. I can tell you, Hibernate, in my case, generates around 5,000 SQL statements. So we have here a lot of room for improvement. And also the question is if this is a good idea if we use the same DTO for all our methods in the controller. But let's get back to the presentation. And what I've shown you is some problems. And I tried to group them into two categories. The first category I call too much. So first of all, when we do that, as we did in the example application, we probably do kind of overfetching. Not only the n+1 select problem is an issue, but maybe we also send too much data. So as you may have seen in the DTOs, I also map the IDs. Do I really need the IDs? For example, when I get the data, do I need all the details of the customer if I get the purchase order? These are all questions that are not solved because we just created an API based on our entity model. On the other hand, if we use the same DTO for changing, we probably send data over the wire that we are not allowed to change. So for example, the IDs, I think they cannot be changed anymore once they were created in the database. On the other hand, we have the purchase order date, and this date is created when the purchase order is created. And that's also something that we don't want to change. So if we just do a one-to-one copy and then blindly map the DTO model to the entity or vice versa, then we probably create some problems with that. On the other hand, we have the exact opposite problem, and I call it too little. That means maybe we don't get enough data. So not in my example, but if you think about maybe your example in your projects, you may figure out that in some cases, we don't have enough data from the response. And this will result in multiple requests, or if we need to fetch data from the client in multiple requests, we move this n+1 select problem that we've seen before that was caused by Hibernate lazy loading mechanism. We will move that to the client side, and moving that to the client side is even worse because you have the latency, so the request will take a while from the browser to the server, maybe. So that's under fetching. And on the other hand, we have under storing. So if we have like a business transaction and we have to do multiple requests to fulfill this business transaction, we have a problem because we don't have any distributed transactions from the client to the server. And in that case, we will get a problem, for example, if the first request is successful and the second one could probably fail. So we have to think about that. So these are two issues that we get from this blindly mapped API. Now, the point is I very often see that in production with my customers because if we have an application that is like client-server application, sometimes the teams are split into front-end developers and back-end developers. And sometimes the back-end starts creating an API without knowing the requirements of the client. So if you're doing something like full-stack development, or you have a close collaboration between the front-end and the back-end team, probably these problems will not happen. But very often you have really a separation of the teams. Probably the API and the client is not created in the same sprint, for example, and then this will lead to such problems. Now, how can we improve the situation? And in the project, I was proposing to use the CQRS pattern to add, first of all, some more semantics to the API, and on the other hand, to improve the performance. Now, what's the CQRS pattern? The CQRS pattern was first described by Greg Young in 2010. By the way, here in the footer, you see the link to the original document. And people that know CQRS say, oh no, CQRS is way too complicated. We don't want to use that in our project. But the point is, if you read the document, you will see that Greg Young is introducing the pattern in several stages. And this picture here, that's the final stage. So the CQRS pattern, if you follow all the concept that Greg is describing, you end up with a separation of the commands and the queries, but also with something in the backend that you have two data storage. And here you see on the arrow, it's written eventually. So you get eventually consistency because you also split the two databases. But the question is if you really need that or not. So you can also go ahead and introduce CQRS, but keep it simple. So just split command and queries. You can still have the same database. This doesn't really matter because this will already help to improve your code. And if you introduce that, then you will probably have something like that. So you will get create order command, for example. Then you have some command handler, whatever that could be. And then this will write to the database. And on the other side, you have like a find orders query, where you have the query handler that accesses the same database and returns data. For example, you can also use views on the database side to simplify that. Now the query side is quite simple to implement. Maybe we should focus on the command side, and the talk is called CQRS meets modern Java, so I like to use some modern Java features to implement the command side. And the first thing that I need for both the commands and the queries are immutable data structures. And in Java 16, Java records were finally released, and they represent immutable data. We see here another example. For example, we want to have an add item command, and instead of sending a whole purchase order or a whole purchase order item, we just send the minimal data that we need to fulfill the command. So in that case, we just send order ID, the product ID, and the quantity, and that's all the data that we need. And the good thing about that is that it's now obvious that this command will add an item. On the other hand, if we have just a RESTful API, we maybe see a put request or a post request to add an item, but we don't really see that, or we don't read that in an open API specification, for example, because there we just have a post with some DTO. The other thing that we may use is seal classes. Seal classes is introduced in Java 17, and you can use that on classes or interface to restrict the extension of your inheritance hierarchy. So for example, here we have a shape and we say that's a seal class, and it just permits three subclasses: circle, rectangle, and square, for example. We will see in a minute why I use that, because it's very often not very obvious what to do with sealed classes. Then we have something called switch expression that was added in Java 14. And the switch expression, in contrast to a switch statement, can yield some results. So for example, here we switch colors, and then we return the color as a string, for example. And what's interesting with the switch expression is that it must be exhaustive. That means in this case, the color just has three values: red, green, blue. If we add, for example, another color like yellow, and we don't use it in the switch expression, then we will get the compile error that says that we didn't cover all the cases in our switch. Then something very important, in my opinion, is pattern matching that was introduced in Java 17 for instance of operator, and in 21 for switch expression and statements. And pattern matching means that we don't have to do an additional cast, for example, so we can directly switch the case here with circle and define a pattern with the C, and this C we can then use to access the content of, in our case, the circle or the rectangle in that case. And finally, with Java 21, we also get pattern matching for records. It's called record patterns. And there we have kind of a destructor that we can use, for example, in an instance of, or also in a switch statement or a switch expression to access the content of the pair or the components of the records. So let's go back to the code and see how this looks like. The code here will be in the CQRS project. And the CQRS project is now split in two parts. So we have command side and the query side, and I also do that on the package level side. And what we have here is a sealed interface or the command. And this sealed interface has three subtypes. So we have a create order command that just uses a customer ID. By the way, for the commands here, I also use Jakarta validation that I can define some constraints. For example, the customer ID must be at least one. Then we have an add order item command with an order ID, product ID, and quantity. And finally, we have a command that is called update quantity command, where we can change the quantity, and there we just need to pass the order item ID to do that. I just use here the seal interfaces to have kind of a namespacing. So if I have an order, maybe I have customer commands, I have product commands, so I can split them nicely into some namespacing. And if we have these commands with the seal interface, we also can then use the switch expression to handle the commands. So we have just one method, it's called handle, and it gets an order command, and then we have the switch expression. And here we use also the record pattern to directly access the customer ID, for example, from the create order command, and then we pass the customer ID to a order service, for example. So what happens after the command, it doesn't really matter. So it doesn't matter if you use domain-driven design and you have a kind of a clean architecture, or you have a create, update, delete, CRUD application with just a service with a layered architecture. It doesn't tell you how you should structure your code. It's just about splitting order or commands and queries, and in that case, we just treat the order commands here in the command handler. The controller that we have then could look differently. So it depends a bit what you want to do, because in the traditional way, we have a RESTful API. So we take advantage of the HTTP verbs like get, post, put, and this adds semantics to our API. But if we have commands, the semantics is not in the API methods, it's in the command. So, for example, we could go ahead and use these RESTful IDs to also build an API with commands. So we could have a post mapping with create order that is sending the create order command. Then we have a post mapping to add items. We also use a proper URL to map for the resource. We have the add order item command, and so on. That's one way how we could do that. But because commands is the thing that we are sending, we could also go ahead and just create a command controller, and that is just getting commands. So we don't need really RESTful API. It's just enough if you have a post mapping that is getting commands. And to make that work, by the way, we have to specify things, because the order command now is an interface, and Jackson that is used in Spring Boot to do the JSON serialization needs to know which command exactly, so which subclass of the command is being sent. And so we need to do two things. First of all, we need to define the subtypes. So additionally to something that we already have here with the sealed interface and the permits, we also have to tell Jackson that there are three subtypes of the order command. And on the other hand, we have to add some additional data to the JSON structure that Jackson is able to map the data to the right class or to the right record. And this can be done with the JSON type info. There are various ways to do that. I choose simple name. And this means if we have a look at the requests that we have to send, so let's have a look at the create order command. Then we have this add type attribute that is in the JSON structure that is used to for Jackson to know that it has to create a create order command if the data needs to be serialized or deserialized into a Java record in our case. And that's very simple. I know it reminds you maybe a bit into JSON because now we have kind of a remote procedure call API and no longer a RESTful API. But as we have the commands, this is what we like to have. And if we have a look at the Swagger UI, for example, this should run here. But I have a problem with it method. What is happening? Okay, somehow it doesn't work. Probably it doesn't work anymore because I updated to Spring Boot and I didn't check it. But let's fix that. I'm sorry for that. Let's go back to 3.5 and rerun the application. Now it works again. It was exactly the case. So be careful if you're using Spring Dock with the newest Spring Boot version. Now we have both controllers. So the first one looks more or less like a RESTful API, as I told you. And the second one just has the order command. But again, here, the OpenAPI definition knows about that. So we will directly see that we have an add order item command, a create order command, and an update quantity command. And these commands are exactly the point about understandability that you add when using CQRS in your API. Because now instead of having a post command that gets a purchase order DTO, if you look at, for example, your Angular or React client, you will find somewhere an order item command that is sent to the server. And in my opinion, if you have kind of this single page application with an API that are very tightly bound together because they belong together, because they form a single application, then this approach adds way more semantics than a RESTful API. So we have the commands, and now the question is, how can we create queries? Now, chaining data with Hibernate has a lot of advantages because you have like cascading persistence. So that means if you have like our structure with the purchase order and the items, we just have the purchase order, add the items, then we can save it with Hibernate, and it will automatically also save the dependent parts of our nested structure. But when reading data, we probably don't want to read entities because entities are there to change data. And we also need or want this data immutable. So our return values from the queries should also be Java records as an immutable data structure. Now, this is not possible currently if you're using Hibernate, but there is a framework called Juke. or JOQ. And Juk is a library that abstracts SQL, but not like Hibernate, where you have kind of OR mapping. With Juk, you just get an abstraction of SQL. That means you have a domain-specific language that is a Java domain-specific language, or a Kotlin or a Scala domain-specific language that you use to formulate to define your SQL statements. And on the other hand, you have a Juk generator that is using the database and then generate Java classes. If you're using Hibernate and the MetaModel API with Criteria API, this may sound very familiar because it's the same concept, but with the difference that you don't do a mapping between your Java classes and your database. You just use the database and generate the Java classes that you need. I just see a question in the chat from Andres. And the question is, can you comment on pros and cons of using CQRS versus GraphQL? For reading, so for the queries, GraphQL would be a very good alternative, in my opinion. Maybe, but you cannot directly specify the SQL statements that you want to use. We will see that in a minute. And for the commands, you have mutations with GraphQL, but I really prefer the commands in that case, because if you are going all in finally with CQRS and you also want to have like a split between the databases, you usually introduce event sourcing. And commands are something that comes into your system, and then you have your business logic, and if the command is successful, it will create an event, and the event can be used in the event store and can be used to populate the read data. So in my opinion, commands are adding more semantics than GraphQL, because they are limited. So you just tell these commands are possible, and they also add semantics, as we have seen before with the create order, add order item, update quantity. That's exactly what you want to do and what it does. And so it adds more semantic that GraphQL on the command side. Cool. Now, Juk, why can we use that? So commands could be used to insert, update, delete data, for example. With Juk, you could generate minimal updates. That's a possibility. But for me, the real advantage lies in queries. Because if we think that we want to return from the query the same structure, for example, the order and the order item, then you can do that with Juk. Because Juk provides something called the multi-set value constructor. And that's something that SQL is not able to do, because if you create a SQL statement, the result is always a table. But multi-set uses some functionality from the database, like JSON functions, to emulate such multi-set functionality. So let's go back to the code and see how this works. So we have a query side, and on the query side, we have a query controller. This one has just the method, so it's a get mapping. And here, for convenience, I created a find orders record that holds the first name, the last name, the offset, and the limit. So it has the information that I use. And then I delegate to the find orders repository. And before we go to that, we think about how Juk can generate the meta model. The meta model is generated from a database. So either you can use directly your Flyway or Liquibase scripts if you have those for database migration, but this is a bit limited because it doesn't allow you to use the whole functionality of your database. And maybe if you have an older database, you may have store procedures or functions or special user-defined types, and you can generate also metadata out of those. So one of the the good approaches is you spin up your database with test containers, then you execute Juke, or then you execute flyway scripts, for example, and then you execute the Juke generator. And that's exactly what I did here in my project. I don't want to go too deep into that, but there is a test containers Juke codegen main plugin. It was created by Siva. He was a former employee of test containers, and he created that project because it's very common to have such a setup. And what Juke is generating, it generates classes per table, for example. So you get a customer class that represents a table. And here we have constants with also additional information. So for example, we know that's an ID, it's a big int, it's identity, so it's the primary key. And what Juke is also generating, it generates records. And records are an implementation of the active record pattern. So we can use the records to read and write data in the database. The difference between records and Hibernate or JPA entities is records are just a representation of a row in a database table. So it has no mappings like one-to-many, many-to-one. It just maps the columns of the database table. There's a question from Ronald. He's asking, does Juke replace JPA? It can replace JPA. I have a second talk in like 20 minutes about do you really need Hibernate, where I talk about that. But just to make it short, Hibernate and Juke can be used in combination if you like to. It depends on your application. So if your application reads a lot of data and just does minimal updates, for example, like I do, then you can just omit Hibernate and just use Juke. This would work. But you have to write maybe insert and update statements or use this active record pattern to store the data, so you don't have the convenience of, for example, cascading when writing or deleting data. Then there's another question, what are the benefits of records instead of using Java classes with Lombok, for example? The point is that records are, or not these records, let's go back to the other records. For example, the customer here, that those are immutable structures, and you don't need Lombok, for example, for that case. So the Java record has just one single constructor. So that was we see here directly behind the name of the record is kind of the constructor signature. And then we get equals hash code and toString generated for the record. So we don't need Lombok for that part. I really don't like Lombok very much because it's an annotation processor. I don't really see what it generates. For example, here, I mean, I also don't see what it generates because it's a Java construct, but it's great to have that and don't use Lombok anymore for immutable data. So that's my opinion. And the other thing that's great is that we also have this record pattern. So the pattern matching for records, where we have this deconstructor that we can use in instance of, or also in the switch expression or in the switch statements. So finally, if we know more or less how it could work, we can have a look at the query. And here we have the query to find the purchase order. And here the purchase order, in my case, for CQRS is exactly the same as the purchase DTO from the traditional implementation. So we have the purchase order, we have a list of order items, we have a customer, and I want to read that tree data structure in a single query. And I can do that because I can nest the query. So I just declare what I want to do, and I don't map that in a ways. I just say I want to select order ID and order date. Then I have a row value constructor where I can create an object from parts of the query. And finally, and that's the most interesting or the most convenient functionality of Juke, we have this multiset where I can create a subselect and use the order items to get the data from there. And then we have mappings in between. So the mappings are type safe. Everything is type safe because I'm using the generated classes here. So if I write the wrong name, for example, then it doesn't compile for sure. Or if I update the database and say, for example, postal code is wrong, it's now called zip code, and I regenerate that from the database, the code will no longer compile. And I am also type safe. That means if I use something that returns a string and my product has some other definition because it has an ID, a name, and a double, for example, then my code will also not compile. So I have compile time safety here in my SQL code. And that's an advantage because you also can create SQL with other tools, like you can use Spring Data JDBC, for example, with the JDBC client, or you can use Hibernate with native queries, but there you don't have this time safety. I mean, you have perfect or sophisticated call completion in IntelliJ nowadays, but you don't have this compile time safety, and that's something that's quite very helpful for Juke. But for sure, if you're using Juke, you need to know SQL. So you need to know how to write those statements. And now if you execute this find method, then we can see what Juke in fact is doing, because Juke is really only running one single SQL statement. So what we see here is this statement. So it's just one. And if you look at the sample result that we get here, we can see that ID and order date are regular columns in the result set, but nested and multi-set look kind of, I would say, like JSON. And the reason for that, it's because Juke is using JSON functionality that most of the databases now can use. And so we have really a single select to read all the data into our nested structure. Now we have some other questions. Could you recommend me some good book about CQRS? I would really start with the article that was written by Greg Young in his original paper. Then there is also a blog post from Martin Fowler where you can read about CQRS. And that's more or less everything you need to know. So you really need to know, you make a query side and a command side, and you split that, and that's okay. That's the first step. And if you read through the book or the document from Greg Young, you see that there are other stages like event sourcing at the end that you can use to completely split both parts. Then Franco is asking about the database column with the blob data type. A blob is just a byte array, finally, in Juke. And if you have other complex data types, they are generated. So, for example, if you have domains in the database or user-defined types, you get the class for these. So, for example, I could create like a user-defined type price. Instead of a string, I could have a user-defined type that has price and the currency, for example, and Juke will generate also a Java class. By the way, if you have functions or stored procedures, Juke is the best or the simplest way to call them, because for each function or all each stored procedures, Juke will generate a Java class. So you can directly instantiate the Java class, pass the parameters, and execute that. You don't have to deal with any callable statements and complex return types. Then Esteban is asking, what do you recommend to use in case an app has many, many big complex queries? The question is, who is writing the queries? I mean, this query is not that complex, it's just long, right? so it's not complicated. The benefit of writing the queries with Juke is also it's database agnostic. So you can write a query and have Oracle's database, for example, and then suddenly the management decides now we want to go with Postgres. You just switch the database. So like you have this database independence with Hibernate, you also have the database independence with Juke. First of all, sometimes what's asked about CQRS, about Juke, sorry, is you have kind of a data scientist or or a DBA who gives you a very complex SQL statement in a string. How can you transform that to Juke? First question is, do you really need to transform that? Or you can also use that directly with Juke, so you can also execute SQL statements as a string. So that would be a use case if you have the data scientist and he gives you every day a new query or it updates the query constantly. Maybe then that's not a good idea to use that. Or on the other hand, we have translate juke.org, or that's not the correct address, juke translate. Let me see. Translate, here we have it. And Juke Translate can translate SQL statements from different dialects, for example, from Oracle to Postgres or from Postgres to SQL Server. But it also can generate from SQL statements to Juke Java code. And then you can transform that with this tool. This tool can also be used from command line, and then you get the transformed query, for example. Cool. Okay. So let's go to the conclusion because we are already more or less out of time. In my opinion, especially with the commands, when you separate commands and queries, is you improve the understandability. So you really get commands that you also find then in your client code, for example, and you avoid over and under fetching. You also don't send data that is not needed over the API because the commands are very small. So you just send the data that you really need to execute the command, for example. And if you use Juke or any other tool that with nested structures, for example, then you don't need the mapping between entities and DTOs. So because you directly create the records from the query, or you just have the commands that are updating the entities. So you never need the DTO entity mapping. And finally, if you go all in with CQRS, then you enable an event-driven event sourcing approach with separate data stores, for example. So we then have a full-fledged CQRS implementation. But be aware, you don't need that. So if you have a simple application, you don't want to split that, you don't have to. And that's sometimes a misunderstanding of the CQRS pattern because people think I need to have this separate databases, this event storing or event sourcing, but that's not entirely true. So you just can use the idea of CQRS. By the way, I didn't said that before, but CQRS was inspired by CQS from Bertram Meyer. He created the Eiffel language, and what he said with CQS, a method can only change data or fetch data, never fetch data and change data at the same time. So that was the inspiration also for CQRS. So that's it from my side. Are there any more questions?
Thank you very much, Simon. Sorry, thank you very much, Simon. No, I don't see more questions, but this was a really interesting talk. So, yeah, thank you very much to you, and thank you for all the folks. Muchas gracias a todos los que hicieron preguntas. Thank you very much for all of you that make questions. And well, hope to see you in another talk soon. I think I saw one talk of you in another conference, and it was also interesting. Well, so see you. Thank you very much.
Thank you. Muchas gracias.
Muchas gracias.